All right, let's talk about the telescope, but maybe not in the way you're used to thinking about it. We're going to dive into how its invention wasn't a single aha moment, but really a powerful story of convergence.
So how does a great invention actually happen? We all have this image in our minds, right? The lone genius in a lab, a light bulb suddenly flashes on. But is that really how history works? Let's take the telescope. Was it just one person's brilliant idea? Or was it the result of something much bigger?
While the truth is, the telescope wasn't a single invention at all. It was more like a destination. Think of it as the exact point where two ancient, powerful rivers of human knowledge, rivers that had been flowing separately for millennia, finally crashed into each other. And to really understand the invention, you have to follow both of those rivers from their source.
Okay, so let's start with our first river. We'll call this one the race for precision. And really, this whole track is about one single, obsessive human quest, trying to figure out exactly where things are in the night sky. I mean, with pinpoint accuracy.
And wow, what a quest it was. This was a relentless march, a slow, steady improvement over centuries. You had the ancient Greeks with their armillary spheres trying to model the whole cosmos. Then in ancient China, the brilliant but simple sighting tube. It didn't magnify anything, it just let you aim better and cut down on errors. Fast forward to the Islamic Golden Age, and they're building these enormous mural quadrants, so big and stable they made star charts unbelievably accurate for the time. And all of this history, it all leads to one guy in 16th century Europe who took this entire tradition and pushed it to its absolute breaking point limit.
That man was Tycho Brahe. His obsession with mechanical accuracy got him to this incredible number, 2 arc minutes. Now, what does that even mean? Well, to put it in perspective, that is the equivalent of being able to see a single human hair from more than 20 feet away. Just think about that. It is the absolute physical limit of what the unaided human eye can possibly do. Tycho had perfected the mechanical side of measurement as far as any human could.
So why was that the limit? Why couldn't he get any better? It wasn't because his instruments had flaws. No, the problem was something else entirely. It's called astronomical seeing. You know that shimmering you see from stars at night? That's it. It's the blurring and distortion caused by our own planet's turbulent atmosphere. So Tycho wasn't fighting his tools anymore. He was literally fighting the air itself.
And that's the crucial point here. Our first river, this whole field of observational astronomy, had just slammed headfirst into a physical wall, a brick wall. It didn't matter how much bigger or better you built your instruments, you just couldn't solve the problem of a wobbly atmosphere. To go any further, they needed something completely new. The need wasn't just there, it was desperate.
Okay, let's leave that problem hanging for a second and jump over to our second river. We'll call this one the quest for clarity, and this is a totally different story. We're not talking about gears and measurements anymore. We're talking about light itself and the long journey to understand it and to build things that could control it.
And you won't believe this, but for more than 1,000 years, this entire quest was stuck, totally dead in the water because of one massive fundamental mistake. The greatest minds, people like Euclid and Ptolemy, believed that our eyes worked by shooting out invisible rays to feel objects. Seriously. It wasn't until the 11th century that the incredible Islamic scholar Ibn al-Haytham came along and proved the intromission theory, the correct one, that light actually enters our eyes from the world around us. What a revolutionary shift in thinking.
So how did he do it? How did he overturn 1,000 years of common sense? He used experiments and evidence. And his logic was just so simple and so powerful. He basically asked, okay, if light comes from the eye, why does looking right at the sun hurt so much? It's so obvious to us now, but that simple question completely shattered a millennium of bad theory. He showed that seeing is a passive act of receiving light, not an active one of sending it out. And that was the theoretical key needed to unlock optics.
But, having the right theory is one thing. You still need the right stuff to work with. And for centuries, the main material, glass, was just awful. It was full of impurities that gave it this kind of gross yellow-green color. You just couldn't make a truly clear lens out of that stuff. It was useless for optics.
This is where the breakthrough happens, and it's a chemistry story, really. It came from the master glassmakers in Murano, Venice, around 1450. They created something called Cristallo glass, and it was a total game changer. They used super pure quartz, but here's the secret ingredient. They added manganese dioxide. It acted like a decolorizer, canceling out those impurities. And the result? The world's first truly transparent glass. This was it. This was the material that the science of optics had been waiting for.
So, okay,
The material is finally ready, but you still need people who know how to shape it into lenses. Where did that expertise come from? Well, it came from sheer market demand, and you can thank the printing press for that. Think about it. Before the printing press, not a lot of people needed to read. But afterwards, suddenly, books are everywhere, and a huge chunk of the population realizes they can't see the letters clearly. A massive new market for vision correction just exploded, and that demand created a whole industry of skilled eyeglass makers, grinding out lenses day after day.
Okay, so let's pause and take stock. We have our two rivers, and they're both roaring now. One is the desperate need for a new astronomical tool. The other is the new science of optics, with the right theory, the right material, and the right craftsman. And now, we come to the convergence. The year is 1608. This is where it all comes together.
It was truly a perfect storm. All the pieces were finally in place. Let's just run down the checklist. You've got the need, astronomy is completely stuck. You've got the theory, everyone now understands how light and vision actually work. You've got the material, that beautiful clear crystallo glass is available. And finally, you've got the parts. All these eyeglass workshops are just full of lenses, convex ones and concave ones. All the ingredients were sitting right there on the table, waiting for someone to put them together.
So who was it? Who was the genius who finally connected the dots? A famous astronomer? A brilliant university professor? Nope. The final step wasn't some grand, planned-out experiment. It was a simple, hands-on discovery by a regular craftsman, a Dutch eyeglass maker named Hans Lippershey. He was just in his shop, he picked up two different kinds of lenses, held them up, looked through them, and bam! He saw that a distant object looked closer, a discovery born from pure craft and curiosity. But here's the thing. Once that invention, born in a simple workshop, was out in the world, its scientific potential was just unleashed. Almost overnight, it opened up not just a new world, but a whole new universe of possibilities. Because while it took a craftsman to put the pieces together, it took a scientist like Galileo to see what it could really do. He heard about this new spyglass, and he didn't see a toy. He saw the solution to the problem that had completely stumped Tycho Brahe. He immediately built his own version and pointed it at the night sky.
And what he saw, well, it changed human history. I mean, look at this list. With a simple lens just 1.5 inches wide, a size that was basically limited by what the eyeglass industry could make, he saw moons orbiting Jupiter. That alone proved not everything revolved around the Earth. He saw the phases of Venus, craters on the moon, and stars no human had ever seen before. The old, perfect heavens were shattered overnight.
And this is where science and craft fully merged into this incredible feedback loop. While Galileo was making these shocking observations, the mathematician Johannes Kepler provided the missing theory. He explained why and how the lenses worked, and once he understood that, he was able to design an even more powerful telescope. The craft-based invention was now being supercharged by scientific understanding. And that, right there, is the big takeaway from this whole story. Great breakthroughs are rarely a single bolt from the blue. They're the convergence of different, seemingly unrelated fields of knowledge. In this case, mechanical precision and optical science, built upon centuries of slow, patient work by countless individuals across different cultures. Which, of course, brings us to today. It makes you wonder, right? What are our modern two rivers? What seemingly separate fields, maybe artificial intelligence and biology, or material science and quantum computing, are flowing towards each other right now, about to converge and change our world all over again?